Hi guys, it's Miss Howell. We're going to go over Module 8 now that we've returned back from Christmas break. Hope you had a wonderful time on your Christmas break and relaxed and didn't think at all about anatomy and physiology. I hope that you are ready to go though, because we need to move really fast through this section. I'm going to make this return to class as easy as possible for you though, because this chapter, Module 8, has got a lot of really intricate nitty-gritty details that I'm not going to ask you to read. So the first section of this text in Module 8, I'm going to allow you to just skip that. If you don't care to read it, I am perfectly all right with that. Of course, if you are super interested, you are more than welcome to go back and look at it and learn these things on your own. But I have plans for some other things later on, and I just feel like these serious details that are listed here are a little too heavy for this grade level, to be honest with you. So you're only going to have to read the second half of the chapter, and that'll be next week or after next week, so don't worry about it. So for right now, we're going to talk about the brain. I'm going to give you what you need. You've got a copy of your guided notes that you were given in class. We're going to go over most of this in class, but I'm making the video available for you just in case you need to go back and review, fill in any blanks that you didn't get, and get any more details that you might want. So this is going to take about 10 minutes, and let's get started. All right, so we're talking now about the brain. In Module 8, the central nervous system, it's going to cover two things, the brain and the spinal cord. So this today is the brain. The central nervous system is made up of the brain and the spinal cord. The brain itself weighs about 3 pounds. So what I usually do to help me visualize things like that is I think of a pound of hamburger meat because, you know, I'm in the kitchen all the time cooking for my family, and I have purchased hamburger and I know what a pound of hamburger looks like. So and I know what it weighs and what it feels like when I lift that package. So your brain weighs about 3 pounds. That 3 pounds on average is about 3% of your total body weight. The average adult brain has something like 100 billion neurons within it. The brain requires lots of energy, and all cells of your body use ATP as their energy source. So the brain requires a lot of this energy in the form of ATP to be able to receive and send these action potentials or these electric impulses and signals to and from the brain and the rest of the body. To create ATP that the body needs and that the brain needs, it's got to have a steady supply of glucose and oxygen. Just like all the other cells of your body, cellular respiration creates ATP using those two ingredients, glucose and oxygen. Even though your brain is only about 3% of your body weight, it takes 20% of your blood supply because it's so important to keep your brain healthy because of all the functions that it controls. All right, so I want you to take out your paper now and define the term hypoxia. You can pause the tape if you need to as you write down the definition. So hypoxia is low oxygen, or a deficiency in the amount of oxygen reaching tissues. When the brain's oxygen supply is cut off, the brain cells that depend on it die. So if you've ever heard of someone drowning or hitting their head and becoming unconscious and needing CPR to resuscitate them, well, it's really important that they are resuscitated very quickly because the longer a person is unconscious and without oxygen, the more and more of their brain cells die. So answer this question on your paper. Can the neurons of the central nervous system repair themselves? Well, if you think back to what we learned before we left for break, and we talked about the peripheral nervous system and the neurons and the neuroglia and all the different tissues that were involved. The neurons of the central nervous system are not able to repair themselves. So when they're dead, they're dead. All right, here's another word I want you to define on your paper. It's hypoglycemia. So pause the tape and write down a definition. So hypoglycemia just means low glucose, a deficiency of glucose in the bloodstream. So you get glucose deficiency or low glucose when you haven't eaten well. Or if you know somebody that has diabetes, maybe they've taken their insulin shot, but they didn't eat well. So the insulin's kicking that they gave themselves an injection with, but they don't have any glucose in their system, so it causes them to lower their glucose to a dangerously low level. That's hypoglycemia. Well, glucose is the brain's only fuel. Remember, it needs glucose and oxygen to make ATP. If the brain lacks glucose, the cells are not able to make enough energy or ATP, and those cells are not going to be able to process the action potentials. When this happens with low blood sugar, low glucose, hypoglycemia, you can't think clearly. You get confused, you might be dizzy, and you may have had these symptoms yourself if you've skipped lunch or had like a lot of sugar early in the day and then nothing else after that, and you have that sugar crash. That's when your blood sugar drops too low. All right, here's another term for you to define. It's called stroke. So pause and give yourself a definition for stroke. So a stroke is a medical emergency that results after brain cells lose oxygen and die as a result of losing this blood. So a stroke is when the brain cells themselves die as a result of no blood flow or no oxygen to the area. So there's two types of stroke. You need to know the difference between the two. One is called ischemic stroke, and the other is called hemorrhagic stroke. Ischemia is an obstruction in a blood vessel to the brain. So it could be a blood clot or a pinched off blood vessel for some reason. So ischemic strokes are obstructions or clots in the blood vessel, and when that happens, blood can't flow beyond that location of the blood vessel, and so everything beyond that point suffers death because it's not getting the oxygen that it needs. 87% of strokes are these types. So if you know anyone who's had a stroke, most likely it's because of a blood clot in the brain. Ischemic stroke. The other one that we need to know is called hemorrhagic stroke. It's like a hemorrhage. Hemorrhagic stroke happens because of the rupture or bursting of a weakened blood vessel of the brain. So you may have blood vessels, well, you do have tons of blood vessels that are feeding your brain the oxygen and the glucose that it needs and removing waste from the brain tissues. Well, if you rupture or burst an area of blood vessel there, then blood just leaks out of the blood vessel and fills like a sponge that area of the brain. So that causes damage to the tissues, and it also causes anything beyond the rupture to not get the actual blood flow that it needs. So everything beyond that point dies as well. So which of these two strokes do you think is the most dangerous, the ischemic or the hemorrhagic? Actually, it's the hemorrhagic stroke that's the most fatal, but luckily for us, it's the one that is much less common. A rupture allows blood to leak, as I said, and the toxic components of blood that seep out and get soaked up like a sponge into your brain's cells kill those cells. It also increases pressure because you're increasing the volume within your head, and there's a skull, that bony skull around your brain, and it keeps everything where it can't really stretch and expand. So the increase in blood volume as it's leaking out inside the brain causes pressure to those cells that it's coming up against, and it kills them as well. In addition to oxygen and glucose, your brain also needs good nutrition. So what are some of the best foods for the brain? I'm just going to give you a few. If you're interested in knowing more about this, you can Google this and find all kinds of information. But these are just a few things that you might want to consider when you are eating out and making choices, or maybe if your mom or dad want to know what you want for dinner. All right, so the first one is healthy fat, like omega-3 fatty acids that are found in fish, are very good for your brain. A recent study that was done at the University of Pittsburgh found that young people that increase salmon and other fish in their diets saw an increase in their test scores. So omega-3s that come from fish like salmon and other kinds will help you to be able to reason and process and retain knowledge and be able to pull that memory back up and perform better on a test. Healthy fats, also from wrinkly nuts like walnuts, also pecans, and they even say almonds, though they're not wrinkly, but it helps me to remember that walnuts are the wrinkly nuts, and they're the ones that are most listed as best for your brain. And they have a lot of those omega-3s like the fish. Another chemical called choline that's found in egg, your body converts choline into the neurotransmitter acetylcholine, and that's absolutely necessary for you. If you remember when we talked about muscles and neurons before the break, ACH or acetylcholine was the neurotransmitter that moves from neuron to neuron across the synapse, and it helps you to conduct those impulses through the brain tissues. Also, blueberries and strawberries are rich in antioxidants. Antioxidants are chemicals that your body needs to help get rid of free radicals that are like poisons to your cells. So blueberries and strawberries, and actually any fruit and vegetable that has a lot of color, blues and reds and greens, which leads to the next bullet point. Kale and other leafy dark green vegetables are called superfoods for a reason, and it's because they are also rich in antioxidants. All right, so now in class we're going to watch this video. You guys have the link here, and it's also typed on your worksheet, so you can pull it up again at home to watch and take notes on the 17, or actually I've written 18 structures that he's going to talk about in the video. And then there are some questions on the very last page of your guided notes, and I need you to make sure that you complete all of those questions as homework if we don't get them done in class, and bring them back next week as part of the rest of your homework for a grade next week. All right, thank you so much for listening. We'll see you soon.